We are moving to the third example, and the question says the foot F of a vertical pole FT. So we have the vertical pole labeled as FT. So the foot is represented with F, while the top is represented with T. So we have it as FT. That's the whole length of the vertical pole. Is 5 meters from A. We have a particular point labeled as A on a bearing of north 60° east. A man walks 8 meters from A to B on a bearing of 300°. Now if you look at this question, we notice that we have the combination of compass bearing and surveyor's bearing together in the question. And after walking on a bearing of 300°, a distance of 8 meters, the man now sees the top T of the pole at an angle of elevation of 50°. Elevation is something that is up. So for you to see something that is at the top, you need to rotate your eye through a particular angle, and that angle of rotation is what we call angle of elevation, which is 50°. And now we have to find A, the distance of the man from the foot of the pole, and B, the height of the pole. Now we take the question, we take the interpretation one step at a time. So from here we first start with the first distance that we are given, 5 meters from A on a bearing of north 60° east. So we draw a 4 cardinal points, north 60° east. This is north, this is east. 60°, so it will be taken from the north to the east direction. So we have 60. The distance for that is 5 meters. So I'll call this one A. This is A. And this one is 60°. So this one will still be labeled as F because we are talking about FTA. So the man from A now walks on a bearing of 300°, a distance of 8. This is 8 meters to B. Now we have this. Now on getting to B, the man now observe the top T. Now this one is the base F of the pole that they are talking about. The man on getting to B now observe the top of this pole. We are giving the pole as FT. So this is T. The man now observe the top T of that pole at an angle of elevation of 50°. That's what the question is saying. The foot F of a vertical pole, FT is this, is 5 meters from A. This is foot F from A. The foot of that pole is 5 meters from A. That's why we have the distance between the foot and A to be 5 meters. On a bearing of north 60°, we have the bearing. That bearing is to be taken from A. So that man now walk 8 meters on the bearing of 300. So this one will be labeled as 300° to B. So after getting to B, the man now observed that the top of that particular pole FT that we are talking about in the question is at an angle of 50° from the position of his eyeball. So we have this. Now the question says we should calculate the distance of the man. This is where the man is. Calculate the distance of the man from the foot of the pole, that is from this place to this place. That's the first thing. And the second question says the height of the pole. Then we get the distance from this F to this T. That's the task that we have there. So from here we need to get the necessary angles. So after getting the necessary angles, so that is when we now know the rule that will be that we are going to use to calculate to solve the questions that they are asking us from the question. From A, the other bearing is almost a circle, and a circle is 360°. So the remaining angle A, we calculate it. So I will call that one NOB. NOB from there is 360° minus 300°, which is 60°. So this angle is 60°, Then after that, we need to get the whole of angle A. Angle A from there is 60 degree plus 60 degree, which is 120 degree. So this is 120 degree. And if you look at this, we have two sides and the angle between them. So when we have two sides and the angle between them, the rule to use there is cosine rule, as that is one of the conditions for using cosine rule. So this one is A, the side facing it is small a. This one is F, the side facing it is F. This one is B, and the side facing it is B. So to get the distance between the man and the foot of the pole, we are making use of cosine rule. So a question coming in says, why is it that this 300 degree, we trace it clockwise? Any three-figure bearing is a surveyor's bearing. And surveyor's bearing generally, they are taken from the north pole clockwise. Clockwise, that is the way a clock operates. So we have it, if you have something like this, this is our north pole. From our four cardinal point, this is south, this is east, and this is west. As we have 300 degree, we have to trace it from here. This is 90, 180, 270, and that's 300. That's why we have it like that. But the other type of bearing, as I've said earlier in our previous lessons, that I'm talking about compass bearing. Compass bearing at times will be clockwise, and at times it will be anti-clockwise, depending on what we have, depending on the combination of the direction that we have. If you have something like this, if you have something like northwest now, maybe north 50 degree west, it will be taken from the north pole as if we are moving towards the western part like this. So that one will be anti-clockwise. But if you look at that north 60 degree east that we located from the diagram too, we took it from the north pole to the east pole. And when I was tracing out the points, you notice that it was moving clockwise. The clockwise movement was because this north and east, they are like this. So moving from the north pole to the east pole, we cannot do that. We can the only option that we have there is to move clockwise. But for some, we have them anti-clockwise. But for any three-figure bearing, which we call surveyor's bearing, the movement is from the north pole clockwise. So to get the distance between the location of the man and the foot of that pole, we make use of cosine rule, using cosine rule. And if you look at the triangle we are using this triangle ABF. Now our cosine rule will be stated in terms of AB and F. The side we are looking for is A. So to come first, we have A square is equal to B square plus F square minus 2BF then cos A. You can see that this is A, we have big A, A. Then the other things we have here, they are the sides that we know. So from there we have A square, B is 5, we have 5 square plus 8 square minus 2 into 8 multiplied by 5, then cos 120 degree. So we have A square to be 25 plus 64 minus 2 into 40. 40 is the multiplication of 8 and 5. So 120 is also from second quadrant because it is more than 90 but less than 180. And we are looking at the cosine. And from second quadrant, cosine is negative. So this one will be minus cos. Now we express 120 as an angle from first quadrant. That will be 180 degree minus 120 degree. So we have A squared to be 89 minus 80 into minus cos 60 degree. And if you check our four-figure table for cos 60, we have A squared to be 89 minus 80 into minus 0.5000. So A squared minus multiplied by minus, that would be 89 plus. We cannot subtract this 80 from 89 because they are not together. So is this 80 and what we have in this bracket that we are having together? So that would be plus 40. So A squared is equal to 129. And this expression is involving square. So an expression that involves square, we have to take the square root. So take square root of both sides. of both sides, we have a square, the square root is equal to square root of 129. So square will cancel square, so a is equal to 11.36 meters. So we conclude that therefore the man is 11.36 meters from the foot of the pole. So for the second part, that is asking us for the length of the pole. So that is FT. This is the angle we are given, 50 degrees. The side facing it is opposite. The longest side, if we look at that triangle we have, that is hypotenuse, and this one is adjacent. The one we are looking for, which is FT, is the opposite side, and the one we are given is adjacent. So when we combine opposite and adjacent, we have what we call TOA. This is tan, opposite, adjacent. So which means from there we have tan theta to be opposite over adjacent. So we have theta is 50 degrees and the opposite side is... So the last part of the question is asking us for the height of that pole. This is the pole we are talking about, that is FT. And if you look at this triangle, we notice that this triangle is a right angle triangle. And we are giving this angle as 50 degrees. So when we have a right angle triangle, the side that is facing it will be labeled as opposite, the longest side as hypotenuse, and the third one as adjacent. Now, if we look at this, we are not using sine rule and we are not using cosine rule. So, do you have anybody who can tell us the suitable formula for that one that we are going to use? Okay, yes, we are using SOHCALTOA. So if you quickly remember SOHCALTOA, we have SOHCALTOA. This one is sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tan opposite over adjacent. We are looking for opposite and we have the adjacent. So we are using tan of the SOHCALTOA. So we have tan theta to be opposite over adjacent. And the value of our theta from that triangle is 50 degrees. So we have tan 50 degrees is equal to FT divided by 11.36. So from here, if you cross multiply, we have FT to be 11.36 sine tan 50 degrees. So if we check our four-figure table or we press our calculator, we have this as 11.36 multiplied by tan of 50, that is 1.1918. And if you do the product, we have FT to be 13.54 meters. Therefore, the pole is 13.54 meters high. Now, you may be asking yourself that of what use is bearing and distance to you? That what is the addition of bearing and distance to you? I just want to tell you this, that to real life situations, things that we see around us, we come across bearing and distance. The first example, thank God for the world we are now. We are in an advanced world where we have all this GPS and we have Google Maps, especially when we are trying to locate a place. When we are going to a place that we've not been to before, we do rely on our GPS and our Google Map. But what if we are going to a place where there is no network? then what do we need? We'll be stranded. So the idea of bearing and distance, the knowledge of bearing and distance is very useful there. Even the sailors, now they don't really depend on technology. They don't really depend on this GPS and so on. They use bearing and distance to navigate. That is what they use when they are sailing the ship. When they are trying to travel to a particular place, they make use of bearing and distance. Another application is our vehicles. The vehicles we drive nowadays, if you look at a point, at times when the wheel is not functioning very well, then we cannot drive the car. The wheel functioning very well is from the work of bearing. At times when you want to turn, you need to rotate your wheel through a particular angle. So if the idea of bearing has not been put in place there, then we won't be able to achieve that. So bearing is very important to life. Even at times we joke with our friends and we just try to make jest of them that you don't know your bearing. So bearing, knowing your bearing is very important. We use that at times in English when we have students that don't even know what they want to do, that they don't even know the next thing to do in their life. We tell them that you don't know your bearing. So bearing, we come across it in everything we do. When you are going to a point 2, when you are going to a particular place 2, and you don't know the direction, you ask. Those people describing the place to you, they are using bearing as well, but they don't mention it. But in our day-to-day activities, we come across bearing. So as students in art class, even commercial or even science students, bearing is not only important to science students. From the instances I've cited earlier, you can see that bearing is important to all fields. So if you want to go for these courses, if you want to go for engineering, if you want to be a sailor, you want to be a pilot, or different fields of life, if you want to be a geographer too, your bearing, knowledge of your bearing is very important. So not limited to only science, even as students in our day-to-day activities. So it is very important for you to master the concept behind the topic, not to cram, but try to understand it so that when you are doing things that involve the application, then you can quickly recall what you have learned on bearing and you know that it is applicable to real life.